What about?
Go ahead and explain it to me, because a lot of people don't know this. 6th grade math. Okay? Just give me an overview to me and explain it to me, because it's been a long time since I've been through 6th grade math. And I'm pretty impressed how the school system's doing.
Oh yeah.
Someone that's got their eyes open and is paying attention.
Yeah, honors math is cool.
Okay, bring it on, brother.
Alright, if a number were to be divisible by 3, it would have to add up to the digits would have to add up to a number divisible by 3. For instance, 12. It is divisible by 3 because 2 and 1 add up to 3. 33. It is divisible by 3 because 3 and 3 add up to 6, which is in turn divisible by 3.
I gotcha. I'm following you. Keep going.
Okay.
Next one. Keep going.
If a number to be divisible by 6, it would have to also be a number that is even and divisible by 3.
Okay, say that again. If a number divisible by 2?
If a number divisible by 6, it has to, a number divisible by 6 would have to be divisible by 3 and be even at the same time.
Well, you lost me. You had me on a roll there at the beginning with the divisible and the adding up. I thought that was interesting, but then the next one you lost me with the same. I want to see more patterns. I'm confused.
Here's the pattern. So basically, if the number's even and also divisible by 3 at the same time, it is divisible by 6.
Oh, since it's divisible by 3, it's also divisible by 6. Since
as long as the number's even.
Okay. All right. Sort of. Okay.
Okay, and if a number was to be divisible by 9, it would have to, the digits would have to add up to a number divisible by 9. For instance,
what's divisible by 9?
Well, for instance, if you were in between 1 and 9, you would have to, the digits would have to add up to 9. If you were in the tens, it would have to add up to 18, 20s, 27, 30s, 36. And you get the pattern, right?
Okay, I'm just going to play dumb.
Alright. For instance...
You're the teacher,
45.
I'm the student.
For instance, 45. It is in the 40s, so it would have to be divisible by...
What are you talking about? 3s, 6, or 9s?
It would have to be divisible by 9.
Oh, 9 times 5. 5. There's no 3, 6, or 9 in there at all.
To prove my thing correct, so 1 through 9, it will have to add up to 9, 10s, 18s, 20s, 27s, 30s, 36s, and 40s. 40. It would have to add up to 45.
So that was my mind that just scattered all over the floor.
Or just a number that is divisible by 9. 4 plus 5 is 9.
4 plus 5 is 9.
So, since that is divisible by 9...
So the answer, 45, yeah, it's a numbers game. 4 plus 5. It's magical, isn't it?
Everything has a pattern.
You know why? That's why they call it mathemagic.
Yeah. Anyway, if a number was to be divisible by 2, this is pretty obvious. It would have to be even, right? Obvious.
Okay.
If a number were to be divisible by 5, which is another obvious thing that you learned in 2nd grade, it would have to end. The number would have to end
with
a 0 or a 5.
Yeah. Okay.
If a number were to be divisible by 10, it would have to end with a 0.
0.
Right?
Yeah, sure.
See? Simple.
Okay, wait, recap on that. So a number that ends in a 0, it have to be tens or whatever. It have to be divisible by 0. 5s. That's a good place. That's the good starting point. So 5s and 10s, for some reason, they're a little bit easier to understand. The other ones, recap on how, reboot me on that.
If a number,
so because I know my 5s, it's like, okay, they're either going to end up in 5 or 0. You know, 5 times 2 is 10, ends in a 0. But it's 1 and 0, 1 and 0. But listen, 5 times 3 is 15. It's 1 and 5. Add them together, you got a 6 there. So I'm a little bit confused. Go ahead. I'm gonna go ahead. I'm gonna leave you that. And
Okay,
I was
I'm
thinking the
gonna
5s and 0 were pretty easy, but then I just blew my own mind there.
I'm going to recap on 3s, 6s, and 9s, okay? So, if a number were to be divisible by 3, the digits would have to add up to a number divisible by 3. For instance, 12, like I said before. 2 plus 1 is 3, right?
3 plus 1, what? Say that
2
again?
plus 1 is 3, right?
Yes.
Right? For 33, that is divisible by 3, because 3 plus 3 is 6, and that is divisible by 3. 36, 6 plus 3 is 11, that's not
6 plus 3 is 9.
6 plus 3 is 9, yeah, sorry. 6 plus 3 is 9. 9 is divisible by 3, right?
Mm-hmm.
And you can keep on going on as long as the digits add up to a number divisible by 3.
So the two digits, you add them together?
Just the digits of the number. All the digits of the number. So here, if you were to take 15, which is divisible by 3, right? 5 plus 1 is 6.
Okay, so you add them together, so it's, and then you get something that's divisible by 3. Okay,
Yeah.
5 plus 1 is 6. Okay.
3 plus 0 is 3. 6 plus 0 is 6.
Mm-hmm.
9 plus 0 is 9.
Okay.
12. Wait, so 2 plus 1 is 3.
Yep, I
1
gotcha.
plus 5 is 6. 1 plus 8 is 9. Right? And then
Yep, 2 plus 1 is 3. Yep. Oh, I totally get it. But you got to go by 3s. 1, 2, 3. Next, 2 plus 4. So is it safe to say that there's a whole bunch of different languages in the world, but mathematics is the same in every language?
Yes.
Interesting. I can disregard that.
Yeah. Kind of.
Okay, keep going. That you just totally nailed it. What kind of mathematics they call it when they add the two numbers together
And notice.
and they compound it? It's like a
Notice-
numerology. I guess
notice
it's a
this.
numerology pattern, maybe. What's actually the word of it? They call it prime factorization.
No, prime.
There's got to be something else. There's another word they call that,
Prime
isn't it?
factorization is something different using prime factors. But notice how if you make rows of 10 like this and you divide out the numbers divisible by 3, which are in boxes, they all go in a diagonal formation, right?
Interesting. Yeah. I see what you got going on there. Good job.
Yeah.
Huh. And then it just goes on and on and on from there until infinity, until you get like this massive spiral of
Numbers.
massive spiral of numbers. What's that called? What's that guy? Who's the guy that invented that thing? The little spiral. Oh, come on. We can think of this.
I don't know, but
The French mathematician, I believe it was.
yeah, but I think it's called the golden ratio.
The golden ratio, exactly. Yeah.
See, if you were to turn the page,
Yeah.
and
Interesting.
I will save the next.
All right.
lesson.
Well, we're past eight minutes. Anything more than 8 minutes is pretty boring. So we're gonna go on. Anything else you'd like to say? Final last words.
The next lesson will be on prime factorization.
Nice. Hey, good job.
You want to make a video on prime factorization right now? You can.
Oh, wait a minute. Did I stop it? I don't think I stopped it.
Hey, you can.
Can you stop it? Yeah, you got.